So we are going to be, oh, people, some of you I just don't know. So yesterday, all about the combining the like terms. Today, the bottom of this page, and just the bottom. I wanted to make sure I wasn't rolling over to the back here. Okay, so here's what we're going to be up to. We are going to use the distributive property. We've done that. We've distributed before. Adding exponents. We're going to add a little something underneath this. We're going to multiply the coefficients. Now, we've chatted about this word before. Coefficients is going to be the big numbers in front. So even if you just wanted to multiply the big numbers, that's cool. And then if possible, combine like terms like we did yesterday. So we're going to combine something that we did before with something that's new. That's how we keep growing with this. So here is the game plan. When we're doing these, the first job is always going to be to distribute. So whatever's outside the parentheses, we're going to multiply times each term on the inside. But I've got to keep my two rules that we've got up above straight. So again, we're going to multiply the big numbers. So 8 times 7 is 56. If I don't see an exponent on a variable, what exponent's there? 1. So I'm going to go ahead, I'm going to put 1s on these. Because when we're multiplying, we also add the exponents. So x to the 1 plus 2 is 3. And as I work my way through, multiply the big numbers, negative 16. Add the exponents. 1 and 1 is 2. Multiply the big numbers. 8 times 3 is 24. Well, Hardy, there's no exponent for me to add here. It's just the x, or x to the first, okay? So this would be the point now, if I can, to combine like terms. But remember, we've got up top from yesterday, like terms. They have the same variable and the same exponent. These all have the same variable, but the exponent's not the same on any of them. So this one is done. I don't have to do a second step. I don't have to do anything else. And that covers me. So sometimes it's just going to be the distributed and we're done. Other times, it gets a little more interesting. So here I'm going to go more with colors to kind of let you see what's happening. Okay, so notice I didn't distribute, I didn't make arrows all the way through, just to the parenthesis that's right after it. Put my 1s back in there for my exponents so I don't forget about them. And I'm going to do the same thing I did in example 1. Multiply the big numbers. Again, use the calculator if you would like. Add the exponents. 1 plus 1 is 2. And then one more time. Multiply the bigs. And there's no other variable to put in there, so we'll put that in. But I do have to be careful when I go to distribute. Oops, I want a different color. Just a minute here. Okay. Whatever sign is with your number, negative 5 in this case needs to go with. Got to take the sign. So negative 5 times x, or x to the first, and negative 5 times positive 3 is negative 15. Now this time, though, I start to look through and I'm like, okay, well, I see this has an x to the second. I don't see any other x to the second. So that one I'm just going to copy down. But when I get to my x to the first, I see that I have two of them. I have 24x to the first, and I have negative 5x to the first. So when we combine our like terms, that's when we're just adding or subtracting. We're not messing with the exponents anymore. So 24 minus 5, or 24 plus negative 5, is positive 19. X to the first. Didn't mess with the exponents. Hardy, you didn't add them. You don't when you're not multiplying. And that's my only plain old number. So I got to do a little bit of combining there. Just a little. But every little bit becomes important, so we do it correctly. And then we're going to see area again like we did yesterday. You're like, same problem, Hardy. Yeah, but yesterday we were doing perimeter. We're not doing perimeter today. We're doing area. So when we're doing area is length times width. So we're not just adding things up this time. And I am going to mention one other thing. We've talked about this in the past, but I'm going to here again. If you ever see terms that have the plus or minus, I would suggest putting the parentheses around. Number one, because it lets us know they're locked together, they're bonded. And it also lets us know if we're multiplying that we got to make sure we distribute to both terms. Because sometimes, whether it's with multiplying or things like this, I don't have to have that one there. With the question being out there, why'd I put the 1? I like to put it in with these so I don't forget to add them in. Because sometimes you don't see it, out of sight, out of mind. So I like to put it in, but you do not have to. So here, I'm just multiplying these two things together. So I'm still going to keep putting my 1s in, at least for the time being, until I'm comfortable with this. So we get those set. And here comes our distributing again, just like we did kind of up in example 2. Multiply the bigs, and when possible, like it is here, add your exponents. Don't lose your x, though. We got to have the x there with it. Multiply your bigs, and there's no x here to add to it, so I just put that in. That would be my area. If, and then we'll do this in the future, if you're given an x value, then you can just plug it in. You can find the area of any value you need. Now again, keep stuff handy. Keep stuff handy. We are going to be moving in the practice over to page 3. And we're rolling through some of the same stuff. So the level 1, I'm not really going to worry about because you've got a good example of that with example 1. So if you're looking for some help, that'd be the place to look. When we get down to level 2, it's kind of like example 2 again. If you've written that down and you try that, make sure your x's, your exponents get added. That shouldn't be too bad. Answers are at the bottom, so you can double check. However, as we get to the back of this page, now it gets a little more interesting because it says express the area of each figure as a polynomial in simplest form. Okay, this one would be just like example 3. So I have an example already ready to go, another rectangle. Triangles we have not talked about yet. So I do have a question. So here, okay, so we already said with a rectangle that the area of a rectangle is length times width. But I have a different shape here now. So the area of a triangle. Anybody know that formula? Yeah, nice. Okay. So you can either do 1/2 length times width, or you can do length times width divided by 2. That would work as well. I'll put both. Very nice. So you're like, okay, well, how am I going to do that? So let's say we're doing number 12 here. So, and actually, I should call that base times height, shouldn't I? Oh, Hardy. All right, hang on a minute here. I got a little ahead of myself thinking on that. I know, that's why I was like, wait a minute, let's do this correctly. It's base times height. Yeah, I mean, it's the same idea. But yeah, I really should be putting base times height there. So my apologies to those of you that are like, I wish I could just sticky note right over the top and pretend it never happened. I know. So you're like, well, how's this going to work? So here's what I would do. I would do the base times height part first. So if we're going to do base times height divided by 2, so 3c times 4c minus 2. Don't worry about the divided by 2 part yet. We're going to handle this top part up in the numerator like we've been doing. So multiply the big numbers, add the exponents. Multiply the big numbers. Okay, there's no exponent to add. Now here's the fun part. I'm just going to put the 2 back in because, again, multiplying by 1/2 is the same as dividing by 2. But if there were answers to look at, there's not on these, this wouldn't be what you see. So I look and I'm like, well, why wouldn't it be? Okay? If 2 divides into both of the numbers that are up top, we have to do that for it to be simplified. So what's 12 divided by 2? They're like, wait, Hardy, you're not asking it that simple. I am. What's 12 divided by 2? 6. Okay, what's negative 6 divided by 2? Negative 3. Okay. So here's one of those situations. There's good, there's better, there's best. This is better. This is pretty good. But this is best. So like if this was a quiz and you gave me this, I'll dig it for like a 1/2 point. I mean, it's not going to be anything huge, but if you get here, you get all the points. So that's something you want to be keeping an eye out for, okay? But have that here. You might even want to put that, I'll be honest, might not be terrible to put that triangle one on your notes just in case. Just copy this onto there, because then you have it when we get to the quiz, and you're ready and ready to go.
Is it the same for right triangles?
What's that?
Is it the same for
Yes. Yeah, triangles are always 1/2 base times height. Sometimes it just gets tricky to find the height, but we're going to give you ones that you're not going to have to be too concerned about with that. Now, this last part's a little bit of a challenge. You're like, ooh, that's kind of funky. So, as we're looking at these, remember again, we're going to find out. Okay? Any variable you have that does not have an exponent, give it a 1. And it works just the same way that the rest of these have. So I'm going to do this one piece at a time here. Well, let's find out. Multiply the bigs. Now, when you're adding your exponents, they have to have the same variable. So I can add the p exponents together. 1 plus 1 is 2. I can add the r exponents together. 2 plus 1 is 3. So all the rules are the same still. Multiply the coefficients. 2 times 5 is 10. Add the p exponents. Add the r exponents. Again, they're different. They got to be the same variable.
What do you need?
2 times negative 15. P, 1 plus 1. And there's no other r's. So I just copy it. Now the one thing I'll say with these, because this is going to happen at some point, you do want to check to see at this point, hey, can I still put anything together? But again, to do any like terms at this point, the variable and the exponent has to be identical. So like, these are not the same. Well, the R3s are, but the P's aren't the same, so I can't put them together. Or here, ooh, the P's are the same. Nope, the R's aren't the same. I can't put them together. That's as far as I can go. Unless,
Actually, why?
what's that?
Why?
Because they have to be not only the variable, but the exponent for the whole term has to be identical for you to be able to put them together.
Wait, so.
So like, let's say this would have been 4p to the third r to the third
So
instead.
it's not negative 16. P to the 7 or 6.
I'm not sure where negative 16 would be coming from.
That's the
Oh, I see what you're saying.
It can solve
No,
the problem.
no, you can't. No, you cannot put all of these together at this point. No,
But it's just stop there.
that's as far as I can go with this one. Yeah, for me to be able to put all those together,
All the variables.
yeah, like they'd all have to be 2 and 2 and 2, or 3 and 3 and 3.
So if that P or if the R was 2, the P
Yeah. If this, like if that would have been a 3, I could have put these together. Or if that would have been a 2, I could have put those two together. We got to be identical. So most of the time, that's just going to be some distributing. One last thing from Hardy, because you knew it was coming. Back to Unit 7. Oh dear, solve by elimination. We always hope we can just add down and get rid of something, but that won't happen every time. So I'm going past 17 because you can add right down and eliminate stuff. But 18. Nice. If I just add down, nothing good happens. But I agree with what I just heard. Why 2? See, I hear the... Now he's busy doing the problem instead of answering the other question. Okay. So here, my question would be, if I'm looking at my x's, can I multiply 8 by something to get 16? So it cancels. And since that answer would be 2... Yeah. So here's basically what we're up to. I'm going to scooch this over. Man, I wish I'd have given myself more room here. Okay, here's what I'm going to do. I'm going to rewrite my first one. Not doing a thing to it, just recopying it. And then on the bottom here, I'm going to distribute that 2 through. Regular old positive 2. 2 times negative 8. 2 times negative 5. 2 times 15. Because again, we did, by doing that 2, now when I add down, 16 and negative 16 cancel. I got rid of a variable. I eliminated one. 8 plus negative 10 is negative 2. Negative 24 plus 30 is 6. What's my one last step to get y alone now? How do I undo multiplying by negative 2? Divide. Okay, so I've got my y, but I'm not quite done. Now, and this is just me, we've done this all along, I just go to the top equation, and I'm going to start copying the top equation until I get to the y. When I get to the y, I know what y is. It's -3. So I go ahead and I plug that in. 8 times -3 is -24. And now we're just back to regular old two-step algebra 1 equation. I got to get my x's alone. Since I need to move this to the other side of the equals, I got to do an opposite. You're like, Hardy, they cancel. Okay, but canceling means there's still a value there. It's 0. That's okay. It doesn't mean it's undefined, because we still have x's left. And you can divide 0, even though it seems strange. You can still plug that in and get 0. But you're not going to have to do as much work on the other one, because when you add down, you're going to be straight on this step already. So, I'm going to keep preaching this till it gets through. If you practice these, the ones that we do, the one sheet front and back each day, you're going to know what's going on when it gets to be the quiz. But if you just shut it down right now, talk to your buddies, eat, and stare at your phone, it's not going to work. It won't at any point. So we got a key online. We got the key up front. If you need help from me, I'm here. I'm ready to roll, ready to help you out. And other than that, we're ready to rock and roll.